Hi and welcome everybody. It's great to have this opportunity to talk to you this afternoon. I'd say this afternoon over here in Denmark. Everybody seems to be leaving the office here at HQ, which is good because it means that I have lots of Lego bricks to play with. But more importantly, I have this great time that I can share some of our great products with you and things that we've been working on. So it's just great to have this opportunity, as I said. I'm going to talk to you today about the EV3 programming app, which is an absolute great way into learning or teaching or even competition with LEGO Education Mindstorms and using the EV3. So I'm just going to press on with that now. So here in Denmark at LEGO Education, I'm part of the middle school team, and I'm a content specialist and also a concept developer. And what I do is I write materials for teachers and students and involved with the Mindstorms team, which is the absolute best place to be. So I'm really excited about everything that we see and especially everything we see through the competitions and all of the engagement, community engagement, the way that young people and adults engage with this great concept. So it's an absolute pleasure to be part of this today. So just moving on, we have the EV3 app. I'm hoping some of you have seen it before. So this is an app that's available for free on the App Store for iPad, and shortly in July will be available for Android as well. So the whole education app experience will be at your fingertips to use with your EV3 bricks and Lego components. So it provides a fun and structured way to learn and program using LEGO Mindstorms. And so this is really the crux of what we're going to look at today and have a good look through. So who's it for? I know some of you might be familiar with the desktop software, but it's something that you can have that's more mobile in the classroom. So obviously laptops are mobile, but even more so, having a tablet in front of you that can go everywhere with you or with your students, it gives even more or less movement around a classroom or a work environment, so that the focus can be more on the engineering and the development of solutions. So it's really for middle school and STEM classroom teachers. I've seen it used in primary schools as well, who use tablets for teaching. It's great for beginning teachers of LEGO Mindstorms. And even those that are not so tech savvy, so those that have had little experience of using EV3 and Mindstorms, it's a great way in. It's great for competition and FLL coaches because obviously there's lots of other apps that you use with mobile technology, and having the EV3 programming app there to do small tests and things like that and demonstrations is a great thing to have in your toolbox. And also existing LEGO Mindstorms teachers and educators who want to just expand the use and look at how else they can teach LEGO Mindstorms within the classroom. So it gives you a more mobile experience, which is absolutely great. So let's take a look at the app now. I'm just going to minimize my screen here, and I've got my iPad mirrored. So I'm just going to open the app. And when we launch the app, we hit something called the lobby space. So this is the area where we can kind of start any activity. So in here, if I just click, we'll start in the left-hand corner, there's some online overlays help, which kind of shows you how you can use different elements of the app. So it says down along the bottom, I've got my programs, I can expand the view. So if I just close that overlay, I can expand and move that back down again. And there's a great way where I can store lots of different programs. What I've also got is a Robot Educator panel here, which comes with 6 tutorials that can get me started with programming with the app. So I'm just going to show you one of those. Well, what I think I'll do first is show you the programming canvas. So if I just go to my programs here and just click New Program, what you see there is a canvas where I can drag and drop different icons. If I want to remove them, I can drag them back down again. So this is really to get a driving base or a robot with wheels to move forward. And here you can change the the values in these boxes or the power. and at that stage then I can maybe get my robot to turn. You can change how many rotations the motors will turn in here. You can change whether it's going to be on for degrees, time in seconds, or on for rotations, on forever, where if you're using sensors, so this is just looking maybe at getting something to move at the moment. So we've got the kind of move blocks here. In this second tab we've got the kind of flow programming blocks. So if I drag this weight block here, within weight you've got all of your different sensors that you can use. So there's limited functionality there compared to the desktop, and I'll go through that in a bit more detail later on. But there's a really good way of introducing new students new to Mindstorms. There's also teachers. It's a great low entry, but also it comes with quite a lot of functionality that you can use and develop within classroom or club or after school for teams. So again, if I just hit the question mark up in the corner, it gives me an overview of the blocks there, on what you have to do some basic programming. So there's a lot of help that's built into the app. So I'm just going to close that again now. I'm going to connect a brick. So I've got a driving brace, an EV3 brick with me. So up in the right-hand corner, we connect via Bluetooth. So I'm just going to connect my brick here, and it should hopefully show up on the screen. Yes, it's on. One thing to note is I'm using an EV3 programmable brick with a tablet here, but you do require a desktop copy of the software. Very often the firmware needs to be updated on the brick, and this can only be achieved through a copy of the desktop software that's connected to the internet, and that's the means of doing that. So that's just something to bear in mind if you're ever going to be using this for competition. If you can bear with me. So I'm just going to go back into my PowerPoint here. So we've had a quick look at the app there. So just to come back to the functionality. The programming is quite light compared to the desktop version. So we only have action and flow blocks. So what I mean by action is where we get the robot to move, where we can get it to display an image, play a sound. We can change the colors of the lights as well. I'm just going to come back down here. So I've got my EV3 has finally appeared. I think it must be too late in the day. And I'm connected. So from this point here, you'll notice up in the top right-hand corner, we've got a download, which is the arrow down, and we've also got a play button with the arrow turning to the right. And you can just touch on that, and it downloads the file to the EV3 brick, and it will run. So it's actually run that program live. What you'll also notice now in the bottom right-hand corner is you can see what I've got connected to my brick. So down over here, you see I've got a mini motor, I've got two large motors, there's a touch switch, there's a gyro sensor, there's a color sensor for reflected light, and also the ultrasound. So all of the components that come with the core education LEGO EV3 set. And it's giving me live feedback. So if I turn a motor, you'll see that the numbers change in under C, motor C. And this is really good for when students want to estimate distance, if they want to just move a robot forward to see how many rotations it goes in a set distance. It's a great way of reverse engineering, and having the tablet, you can almost stand with the robot and you can make those recordings, write them down on paper, and it's useful for when they're doing trials for measuring distances. If I expand this tab, it gives me a bit more information about my EV3. So over here, brick information, it tells me what my current firmware version is, shows me my battery level, how much memory I've used. You can disconnect. It shows me available bricks, how many are available within a classroom. You can also reset motors and sensors from here as well, especially the gyro. Now the gyro is one that very often if you switch on your EV3 and you keep it moving and you want to measure exact angles using the gyro sensor, you need to be able to reset the gyro. With this, the functionality of the app compared to the desktop again, we don't have the ability to reset a gyro, but we can do it manually through the app, just with this switch here. So that's something we've added in there just to tick that box, because gyros, they tend to drift if they're not set at 0 when you start the EV3 brick up. We've got obviously the color sensor there, or reflected light. So all of those things giving us live feedback. Great. So I'll just go back there. So there's lots, even though it's a cut down version of the desktop experience, there's still lots that we can do there. One of my favorite features here, and it is a small but really good feature, is the ability to make notes. So with a purple tab here, and they're color coded as well. So if it's a flow note that you want to put in, so if I wanted to write something about my sensor here, then the yellow will match the yellow of the sensor. And having the ability to write things down as you develop programs, and encouraging students to do that is, obviously when they fail and when they don't quite work, then they can go back and they know exactly what they need to modify if it's specific settings. And having those notes on a competition day is absolutely crucial. Not only to have them on paper, but to also have them within their program. It can save a lot of work when they have to fine tweak and fine tune. A bit like what happens with a Formula 1 race, where even tire temperatures have to be changed within seconds of a race happening, depending on weather conditions. So that would be the connection I make there. Having the ability to fine tune and make notes is really good. Great. So going back to the home menu there, that is my quick overview of the app. So back into here, into my presentation, there's only action and flow blocks, 11 in total, no loop interrupt. However, you can achieve that within a loop. You can just make the loop stop and then have another function after that. There's no what we call data wires, where we can do sort of more mathematical problem solving within the program. There is program migration to the EV3 desktop software. So if I have a program that I've written here and I want to share that, I can via this share function here. So, oops. So back up here, I can share my iPad screen. Here we go. To the desktop. So I've got the program. You can select the program, so the one that's highlighted blue there, and I can share that to desktop via the share function up in the corner over here. It's not, however, backward compatible from desktop to tablet, so it only works in one direction. So if you have a program that you've started to write on the tablet version, and you want to take that then onto a desktop version to finish it off, or to add some more functionality, then you can do that. Great. So in terms of general support, within the software there are 6 robot educator tutorials. So we've got everything from, curve move, moving forward, moving an object, stopping at an object, stopping at an angle, stopping at a line, and also line following. And I'll cover that in the next part of my presentation. There are quick start videos. So within the app, there are videos that will help you to, so in teacher support, sorry, oops, here it is. Sorry. So there's a little video there before we hit a user guide that basically goes through the process of connecting the EV3 brick to the iPad via Bluetooth. So that's what we find here. Okay, I won't play all of that. So there's lots of things that are there to help you. The building instructions for the base model are all inside. There are help overlays like what I've shown you. There's no student workbook or content editing, so you can't sort of record like you can on the desktop version. So it's slightly different. There's only Bluetooth technical limitations there's only Bluetooth communication between EV3 brick and tablet, so you can't connect to motors via Bluetooth or sensors. The EV3 brick firmware update is only available through a desktop version of the software, and the existing activity packs don't work, so things like Design Engineering Space Challenge, we've got the Science activity pack as well, so we can't use those on the tablet, and there's no data logging or graphing environment. I mean, you can, you know, we could say that we could do some form of measuring through this tab here, but it's not really data logging, but we can take readings. You know, we can measure angles, and we, you know, so there are sort of limitations, but it doesn't actually record data, but it can show data changing, so that's something that can be used. Great. So, I mean, at this point, I mean, we've just been through the basics of the app. You know, feel free to drop in some questions. So yes, they can be shared. So only from the mobile app to the desktop. So programs can be shared from the mobile app to the desktop. When you have a program, they save automatically. So that program that I've just written is program 44. So if I wanted to share this program to the desktop, I go to the share function in the top right-hand corner, which is this one, and I want to share that to desktop. So I'm just going to select desktop. I'm going to select my program, and from there I can mail that program. So there's a program, program44.ev3. You can then share that to an email address, or you can, well, I think this is the best, this is the most secure way of doing that. So yes, you can, but you can't come backwards. You can't come from desktop to the tablet app, and the reason for that is there's more functionality. So if you've written a program that's got some data wise, it's just not going to open up on the app. There we go. You can use sensors. Okay. Yes, you can use all of the sensors that are provided within the LEGO set. What I'll do is I'll show you the sensors you can use, because there are some others. So if I've got to wait for, oops, I would be helpful if I showed you my iPad screen. Right, let's just move that down. Okay, so I'm just going to select my wait for icon here. So we've got brick buttons, color sensor. So I can use color sensor, gyro sensor. We can use the infrared. That's obviously not a standard component in the Education EV3 box. We can use a motor, one of the large motors, as a rotation sensor. There's obviously a touch sensor. We have ultrasound, which we have in the box, and there's also we can measure time there. So it's ultrasound, touch, motor, gyro, color. They're all included in the base, in the core set, we call it. You can get a hold of infrared sensors, which are really useful for, you know, detecting the edge, you know, where you've got the wall on the edge of an FLL table, or for selecting objects that are in front. So it works similar to an infrared, sorry, a ultrasonic sensor. So yes, they are the sensors. You can't really add any more sensors, so that's what we have. But there is, you know, you can achieve a lot with that range of sensors. You can have up to 2 touch sensors, obviously from within the core set as well, because it comes with 2. So yes, the answer is yes. So it's coming to Android, and it's on iPad, but no Kindle app. The app is free, so you can download it today if you have an iPad. But like I said, not available for Android, not till July, and then you can download it for free. So it's available for free. Well, it depends on the school. So lots of schools are tablet schools. And, you know, if they don't have desktop computers, or if they have a limited number of desktop computers, you can use them both side by side. So you can you can work within a class, and so depending on the school, you might offer it as a core subject in technology as an elective or in computer science, or it might be something that's built into your curriculum depending on where you're from, where you can do some programming and you can cover the kind of basic terminology of coding through icon-based programming. So you can use it on a tablet, and then after school with a limited number of desktops you can then extend that and go further for competition. But there's nothing to say that you can't achieve successful results as a new team using the tablet app. You obviously, you're not as advanced maybe with the programming as some of the more advanced teams, but as a way of getting into competition, having a lower entry point for both student and teacher can actually be a positive thing, where this, the functionality is less and you build up the momentum at a slower pace. The fact that it's free, and as it's a desktop software now, so you don't have to pay for that either, means that you have everything at your fingertips either way, and you can use it as and when you want within whatever setting you're working. So that's an added bonus. So I haven't tried it. I would say no, because the tablet app isn't backward compatible to the NXT as the desktop software is. So the tablet app will only work with EV3, and the reason for that is, it's the Bluetooth, the way the Bluetooth is set up. It works for EV3, not for NXT. So I would say no. But if you can prove me wrong, please let me know. I would think yes, it would, but there'll obviously be information on our website about that and how you can access all of that. I will say the app will be like a mirror image of the app that we have on iPad. So there won't be any added functionality. To link this with the question I had before about will there obviously be more sensors, or even if it's backward compatible. So it will be it will be the same experience. No, I mean, and this is so a bit of housekeeping when it comes to using a tablet app or a tablet device and another with EV3 bricks. So when I connected my EV3 a moment ago, I'm just going to roll my mouse off here. Its name was EV3. We recommend always that you rename your bricks the minute you set them up. The trouble with having one brick connected to more than one tablet is it could cause chaos, and it doesn't really teach very good practice. If you, and this is where we have to be careful, but that's, I mean, the security measure is when you pair them, there's a code you have to put in. It's just something that we wouldn't say is advisable. It can, if you've got one tablet running 2 or 3 robots in a classroom, then it can cause a lot of trouble within student groups if suddenly their robot has been taken over by somebody else's tablet. So that's the reason I would say as a content writer that I wouldn't encourage that, if that's how I've understood the question, but please let me know if that's not how you meant to ask. Now, just conscious of time, especially for those of you that might be new to programming and new to coaching, and just to show you what else can be done and what can be achieved through the app that's slightly different to maybe some of the things you've seen before. So I'm just going to move through here. Within the app, there's also a teacher support section, and the teacher support section provides a user guide, so that's all of the information you ever really need to know about the hardware and the software, and there's some troubleshooting tips in there as well. There's also a teacher introduction, and there's also an introduction to robotics lesson plan. So there's 9 lessons that you can teach if you wanted to teach this as part of core lesson structure within your school. So there's, for each lesson, there's 2 times 45 minutes or a 90-minute lesson that you can run based around the 6 tutorials. So that's really where you can take those tutorials with groups of students and kind of tear them apart and really get some deep learning, which will equip students fairly quickly with the skills that they need, and teachers to be successful with some basic programming. There's some suggested assessment areas there as well, and direct reference to local curriculum standards. So it's available in 9 languages currently, and soon to be 6 more languages. So you know, we're working with subject matter experts around the world to try and map some of these skills into relevant standard within each country. So I'm going to show you now the teacher support section of the app. So just coming back to the home. So up in the right-hand corner, what we've got there is a teacher support section. There's a teacher introduction, which is information about the app. It talks a little bit about the timings of lessons, and it's kind of general information that I've covered already. But the lesson plan is just a group of 9 lessons. So I'm just going to slowly scroll down here. So there's an introduction there. It covers, the kind of housekeeping rules that I mentioned earlier about making sure that your EV3 bricks are named, also about having the most up-to-date firmware. So it references here, the fact that you need to be using your desktop software to update firmware. You do need to have, it's here, version 1.07e or later in order to use the tablet app with your EV3. So they're things that you need to check. And then we're into lesson 1, building and setup. So it's an objective-based lesson. And it's just a way of getting students to write simple programs. So this first one really just works with sound. So it's just some basic skills, displaying screen, working with some programming blocks and some flow blocks there, and also getting the brick status lights to change. So just a great way. There's some assessment built in there as well. And then we're into a tutorial curved move. So this is where we're taking those tutorials and turning them into lessons. So it's very hard sometimes to have the structure of a lesson if you're a new teacher to something that can be quite intimidating. When you pick up the Lego box for the first time and everything's wrapped in plastic, and you have to pack all of that out before you even get to that point where you're standing in front of the class for the first time, or a group of students having to deliver something and feel like you have control. This is a great place where you can go, and again, within the app, this is provided for you, and you can use it and adapt it how you want as well. So if you decide to print these off as PDFs through AirPrint, then you can kind of make notes and annotate them and change them to suit your needs within the classroom. So now we're starting to get into some sort of more lesser basic programming, where we're getting something to move in a curve. So steering blocks, and I'll show you these mats later. Within the appendices of the lesson plan, there are some printable mats. So this small image here is actually a quarter of the size of an FLL mat, and it prints off in an A3 printer, or you can print it on A4, and then you're just sellotaping it together. So it's something I, as a teacher myself, very often we used to design mats just on a piece of CAD software, computer-aided design, and print them off, and just you could do kind of random challenge-based activities for students pre-season before you get the FLL tournament mats, and it's just a good way of preparing them for challenges that are unexpected as well. So this area up here is, if we blow this up at 2 times A1 in size, this rectangle is where the 2 wheels of the driving base will sit, and the back ball wheel will sit here, and the robot driving base would have to drive forward, collect an object here, and it would use the curved move tutorial to kind of move around this maze, and then it could drop the object here. So there's lots that they can do there. So there's a range of lessons there which can give you that, I say, low entry there's progression. So the lessons get harder as they as teacher and student progress through the course. So it's an introduction to robotics course. That's really the focus of it. So I've got another opportunity for questions. I'm just going to, I think what I'll do is just get through the next part of the presentation, and we'll come back to some more questions. So how the app can help prepare for First LEGO League. I mean, you might not be able to use this app, and when you, so to be realistic, when you look at the first class kind of teams across the world, the level of programming that they have in, without their robots, and the level of engineering, they are reliant a lot on the full version of the software. But what I'm saying is, with the functionality of the tablet app, you can achieve these challenges. And in achieving these challenges, you can learn a lot about programming and also about engineering as well, as you go through even just the build of the base model. And so coming back to where we started, where we've got teachers that are new to LEGO and robotics and Mindstorms in particular, and also they've been put in the position where they have been asked to coach a team for the first time, and they find the full desktop software a bit more intimidating. This is a great place to start. And so this is an image of one of those mats from the lesson plan that's been printed off, so you can see how big it is here, and you can see the piece of sellotape that's joining them all together. So you just have to match up the lines, which is a fun task in itself. But again, it's something that you can have at your fingertips, and there are 4 challenge mats that you can print off there, and I'll show you those as well. And it's a cheap way of getting some challenge out into the classroom. So that's an activity where they have to get the robot to use a gyro sensor to turn and park accurately in parking spaces. So going back to the lesson plan, what we've got there's like a navigational maze. There is one of the challenge ideas, where the driving base has to drive and turn accurately at 90 degrees through a maze. Obviously, where these areas are, where there are crosses, you could build obstacles out of bricks or the available bricks in the box. And it's about precise movements. It's not always about how fast you can go. And I think you're finding that with some of the challenges this year. It's about how precise you can get the robot to complete an activity, and sometimes that means driving slower. We don't dock a space capsule to the International Space Station 1,000 miles an hour. It has to be controlled, and this is again where we're learning good programming and good engineering skills. So we've got stop at line, and then we've got some master challenges. So the first master challenge, the turntable challenge here, is where we're going to get a driving base to park in the different parking areas, and it might be that we can alter that to make it so that it parks in a different order. Go to 1, then go to 4, then go to 2, then go to 3. Maybe they're going to reverse in, maybe they're going to be driving forward, and you can kind of test the students on their ability to get it to park in accurately. We then have another challenge, which is a much bigger one. So this one is a bit more complex in that they have to drive their driving base from this point here forward to pick up an object. They have to push the object so it touches the line here. They then use the gyroscope to turn the robot with the object in its grab at 45 degrees, and they've got to land the object in the center of this target here. So they then release the object, which is the cuboid that's provided in the base model tutorial, and their robot then has to maybe reverse and go find the black line. So that's a classic First LEGO League task. So what will they need to do based upon what they've learned through the tutorials to enable their robot to find this black line, trace it back, and then use the ultrasound to stop a certain distance before an object that's placed over here. So it's we call it like the robot factory, sorry, the LEGO factory. So within our factory here in Billund, we have robots that collect Lego bricks. So, you know, this could be the robot collecting a crate of freshly made yellow system bricks, and it has to move it to a location and then navigate its way to the central area here, and then maybe the robot has to return back home again to be recharged at a charging station. So it's where we connect students to real-life situations. And there's also, if you've had enough by then, you can obviously go to something more challenging and maybe open your first LEGO League challenge, or there are some more design brief challenges there that are a little bit more open-ended. So that's really just something extra within the app itself that just gives some more things that you can tap into to do as a new coach or a new teacher to LEGO Mindstorms. Right. So again, that's one of the maps printed off. That's the one with the, so this is the driving base that you can build for the lesson plan with the sensors. You've got the gyroscope at the top, the light color sensor, you've got a touch sensor here, and you've got the ultrasound underneath, which obviously can detect objects in front of it. The mini motor sits in the front, which activates the arm that comes down and grabs the cuboid. And the objective here is to trace the roadway and get the cuboid to land as close to the middle of this square here, number 2. But then the challenges vary depending on, you know, your student group really. So if you have new students, you can give them a simpler challenge, and maybe if students have used Mindstorms at home or after school, you can give them something a bit more complex. So final questions now really. That concludes my presentation. But please feel free to drop in and ask as many questions. I'll try and answer as many as I can. I am, like I said, content specialist and writer more than a technical expert on some of the matters, but hopefully I'll be able to answer most of your questions. If I can't answer them, then please let us know, and we'll find out somebody that can. So what I'm going to do here, I'm going to go slightly off my brief because I can show you something that's, so this is available in the US now. So if you get the latest version of the LEGO Mindstorms software in the US, so it's currently only available in the US, you'll notice that in the lobby here now, there is a new cog here called Teacher Support, and within Teacher Support there is the lesson plan. So in the US only, you've got the Introduction to Robotics lesson plan. So that's the same lesson plan now that I've just shown you on the iPad. So we've kind of updated that a bit as well to give a bit more clarification. And there's also some discussion questions. So you know, if you want to start questioning some things with your students. So I'll show you that. Also, we've linked that to curriculum standards a little bit more, so there's some assessment rubrics in there as well. So if you want to use it in your core classroom and you want, you know, to get some feedback, then or get some self-assessment and peer assessment going, you can. So that's now available there as an update, which you can download for free again in the US. Hopefully that answers your question. So, printing out the program. I have a program here. Sorry. So my way of printing it is to hold the home button and the there's 2 buttons on the iPad. Depends on what kind of device you have. You can actually take a photograph of it and you can print it from there. I think through share. I think you have to have AirPrint set up. Okay. I don't have it print, but I'm pretty sure that you can print it from, save the Dropbox, Sketch. You might have to, so I'll be perfectly honest, I don't 100% know the answer here. I know how I do it. I normally just take a screenshot using, you know, the function within an iPad. So you can actually take a screenshot of your program like that. So that's a snapshot. Go into photos and you can then print the photo of the program. You can, if you save it as a photo, so that is using the function of taking a screen grab, you can obviously copy and paste that into any form of documentation. So if students were doing something in Word or Keynote or PowerPoint or, you know, any of those apps, you could take the screen dump in there and you could write some notes about it if they wanted to document what they've been doing in class or things like that, or take notes. Okay, so that doesn't exist within the software, but what we do have, so let's look. Right, I'm not going to flow all the way through here. There is a section in here on the tablet app. There's a section on the blocks. Okay, I'll be honest, I don't know specifically if there is a section that talks about block compatibility. So if I go back to my slide. Here. If you think action and flow, everything in action and flow apart from a loop interrupt is included in the tablet. I mean, that is really what we're talking about. It's action and flow blocks. Everything sensor, you know, when we're looking and doing more with sensors, when we're looking at math blocks and data, and if we're creating our own blocks or doing something more advanced, we just cannot achieve that through the tablet app currently. So there's no specific, I don't think there's a sheet that looks like this, but I think what you would find is when you explore those apps, you'll find that out. That's the only answer I can currently give you. You know, we could put more in our user guides, but it becomes harder for people to find that kind of information. I think it's fairly intuitive when you open the app that you can see along the bottom that you write a new program. You've just got your green and your orange yellow tab. Sorry, there we go. Which are your program and your flow blocks. Okay. Good question. Glad you asked that one. So in Robot Educator, so curved move, if I just click on one of these tutorials, so within here you've got need more information, user guide. I'm just going to swipe here with my finger on the iPad. So this gives you the objective. There's a small video there, so that just plays the video of what the program will achieve. Then we've got build it. So we've got here, there's a PDF within which will open within the iPad. So driving base gives me a PDF. And we can just scroll through that and we can pinch and zoom as well, you know, for more information. So the build guide to build everything you need for a driving base is included within the app. There. And then basically within a tutorial again, it plays so if I play the video, so it plays an animation of what the program is doing as the robot is moving. And then what we've got here is a test and modify. So as a good entry point, we provide the program. So we have a sample program. And that just shows you, how those note blocks can be used. And again, as a teacher, if you're writing your own programs and you want to record some notes on them, you can. So this is a program that I can download straight onto a brick and we can reverse engineer. So we can give the students a program the first time, and then they can start to change the parameters. They can start changing the angles, the readings, the speed, and you know, you can set them challenges. They have something that they can have that's, you know, they've got the instructions to build a model where they can learn to collaborate, working together, start using eventually the more complex functionality with the sensors as they go through the tutorials. So it is kind of like a training area. You know, let's learn the skills that we need to be able to build, and learn the skills we need to be able to do basic programming. And then using that combined knowledge, we can then start to use those skills with those challenge-based maths that you can print off to solve challenges where we're working together again in groups and we're collaborating, and we're having to re-engineer and redesign. So one of those challenges, the teacher can start adding objects that are different shapes and sizes, where they then have to alter the mechanism that's going to pick those up. So if I just go back here to Robot Educator and move object, you'll notice that there's like a grab there that they have to build to put on the front of their driving base. So there's obviously the build guide for the driving base, but then there's a build guide for the medium motor module. So these are now attachments that they can build. So FLL is all about, you know, you have a robot that has to achieve different missions, and it's going to have different kind of attachments that are going to go on there. And you know, those driving bases or robots will have to return to a home base and be, again, I look at it, it's a bit like a Formula One car coming in for a tyre change. You know, it comes in, you have hardly any time at all to change the attachments, and what you've got here are attachments that can be changed quite quickly. So the red pins attached here to the driving base can pull out halfway, and then you can remove the medium motor module and unplug the cable, and it's kind of a quick fit extension that enables that driving base to pick up and move objects. So all of the build guides, I meant to mention that earlier, I'm glad you reminded me, are included within the tutorials, and are also mentioned in the lesson plan as well. So that's a good route through if you're new to robotics. It's only working on iPad, so it's iPad only. And like I said, in July it's going to be on Android. But that's all for now. And obviously it's available on a desktop for Windows and for Apple, for Mac. Okay, I think, so within the app, no. The app is, basically we released the app last year, and we've been doing a lot within LEGO Education since then. So I don't know if this answers the question, but it's possibly something that people haven't seen. In our new version of the desktop software, so again, I'm pointing to the US version because that's the only one I have here at the moment. You'll notice that down at the bottom here we used to have a little globe, but we now have a link to the community. So if I click on here, it takes us straight into a discussion area specifically designed for LEGO Mindstorm. So if you have questions, so I think this will show you the direction that we want to go, then you can get those questions out straight away. There might be somebody from LEGO Education that can answer that for you, but there might also be someone within the community that can, you know, answer that as well. So it could be things to do with hardware, with software, experience that people have had. And this is where I really love this, because it means that everybody can be involved, and we can all, you know, be engaged with, we can be engaged with you more, and you can get to be engaged with one another as well, which is a really, really good positive for us. So I've had my Bluetooth on for an hour on my EV3 and the battery hasn't moved, although I haven't been doing that much running around. I think it always pays. I mean, obviously the more you have switched on, the more things run down quicker. It always just pays to, you know, have everything fully charged. I mean, this is I guess stating the obvious here. Always you know, in between test runs, and especially in competition, having spare batteries on charge, having things ready to go, making sure that everything is there. It is useful to have, I think I showed you earlier, the function where you can, see how much battery you've got. A quick view. When if your robot can be half a classroom away, and you can see how much battery you've got left, which is really useful. But it's one of those things that's hard to measure. The more you have switched on, I guess over the course of an hour or 2 hours, the battery level will decrease more. I mean, I know it does on my mobile phone, so it would be similar. Obviously with an iPad as well, you will be draining more battery, but a lot of that's device, depending on the device and depending on the condition of the battery as well in your EV3. If you're using AA batteries and not the rechargeable battery, then I think your batteries will definitely go down much faster. So it pays to use the rechargeable battery when you can. But I'm happy that I've had this opportunity, and obviously there are lots of questions that you have, and please obviously feed those through to us, because we want to know. We want to know more about you and how we can obviously continue to provide solutions that are going to meet the needs that you have. We can't promise that we can meet all of them, but we do want to be engaged with you and in the whole process. I guess my tips really, and the kind of the reason I sort of agreed to do this webinar today is to really encourage you to, if you are struggling to come up with ideas, and especially those of you that are taking this out of the box for the first time, or engaging with this as a technology for the first time, and even for you experienced coaches that you know how easy it is to use the desktop software, and you have programs that you can encourage other coaches to use. Just maybe encourage them some of them to start at a lower entry point and actually use some of these materials and explore how maybe some of those challenge mats can be used to just get people thinking about the more complex issues that you're going to face when you actually come into competition. It's really easy to send out those competition mats and to stick those Lego bricks down, but sometimes for some teachers within a 45-minute time zone, there isn't always the time to set those things up. Whereas you can roll out something that's made of paper, although it's not going to last forever, but it's much easier to make a new one. It's something that is slightly different and involves less color, which could affect the readings on for color sensor and light sensor. They're using something that's black and white, and it gives them success really quickly, especially students that are trying to follow a line that hasn't got too much background noise. It means that they can see the response and reaction of what they're trying to achieve. So yeah, I guess my advice would be to test out some of these other things as well, not to replace, but to complement, to work alongside and to add to your toolbox to expand both student and teacher understanding of how great FLL is and how great LEGO Mindstorms is, and how it can be used in such a positive way to develop those 21st century skills and all the other great things that we see on a day-to-day basis. So yeah, be encouraged there. It's been great having this opportunity to talk to you, and I look forward to seeing any feedback or any videos you post on YouTube of actually using the lesson plan, and those resources would be absolutely fantastic to see.